Hello everyone, welcome to this project demonstration. Today I'll be showing you about the project Automatic Door Control with Password Protection and Bidirectional Visitor Counter using PIC16F877 microcontroller. This system is designed to manage access to a room with a password and automatically close the door when no one is present in the room after a certain period of time. Let's see how the project works. The introduction part shows that there are 4 features in this project. The first one is password-based security. A 4-digit password must be entered in a keypad. If the password is correct, the system unlocks the door and opens it. If incorrect, the door remains locked. Automatic door operation. In this, we use two motors. One is a servo motor and a stepper motor for smooth operation of the door. Servo motor is used for locking and unlocking of the door, and stepper motor is used for opening and closing of the door. Entry and exit tracking. Here we use two ultrasonic sensors which are placed near the door to detect the entry and exit of the person. The system keeps tracks of how many people are inside the room and display it on the LCD display. Auto close feature. If no one are inside the room, the door will close automatically after a short time delay. Let me show you the key components of our project. Firstly, in the front view, there are two components. They are LCD display and keypad. LCD display is the user interface for the system where we can see password prompt, count and like such informations. Keypad allows the user to enter the password. In the back view, there are stepper motor and servo motors. These components are inside the room. The stepper motor is responsible for smooth opening and closing of the door with a special mechanism which converts a rotatory motion to open and close the door. Servo motors handles the locking and unlocking mechanism. In the side view, we can see there are two ultrasonic sensors inside the door. It is used to determine if a person is entering or exiting the room. By analyzing the sequence of triggering and it update the visitor count. PIC16F877 microcontroller unit is the brain of the system. It processes the password input, coordinates the motor operations and handles the visitor counting. Now we are going to see about the working flow of our project. And the first part is password verification. A keypad is used for entering the password. The input from the keypad is sent to the PIC16F877 microcontroller for processing. If the password is correct, the system unlocks the door by controlling the servo motor and stepper motor. This ensures that only authorized user can access the system, providing a layer of security. Next, we have entry-exit detection, which use two sensors. If sensor 1 detects first and sensor 2 detects secondly, it is considered as a entry and the count value is incremented. If sensor 2 detects first and sensor 1 detects secondly, it is considered as a exit and the count value is decremented by 1. The entry-exit detection allows the system to track the total number of people inside the room at any time. The automation of the door movement is based on these sensor inputs. And the third part is automatic door close. The automatic door close mechanism is implemented by the microcontroller timer, and we are using timer 0 here. The intcon register is configured to enable and manage interrupt with the key bits like global interrupt enable for global interrupt and timer 0 interrupt enable for enable the timer 0 interrupt. The option register configures the timer's prescaler value. In our case, we are using prescaler value of 256. And let's look at the calculation here. The oscillator frequency is 20 MHz. So the frequency is divided by 4 and after the division it becomes 5 MHz. Now we are divided it by 256 because it's the prescaler value and we get 0.0195 MHz. We are converting it into time period. So we are taking the reciprocal of the derived frequency value and multiplying it with 256 because the timer 0 is a 8-bit timer. So we are multiplying it with 256 and we get the timer tick duration of 131282 microseconds. Now we are going to calculate for 1 second time delay. For 1 second delay, the timer count is 76 cycles. And we are going to configure our door close mechanism for 10-second delay. So the timer count is 760 cycles. The timer configurations allows the door to automatically close after a design delay. This is the block diagram of our project in which we have connected two ultrasonic sensor in port B. This is used to detect the entry-exit detection of a person. In port C, we have connected keypad which is used to enter the password, and in port D, we connected LCD display in which we can see the password prompt page and we can see the count value once the door is open. In port A, pin number 0 to 3 is connected to ULN 2003A, which is a stepper motor driver. It is used to control the stepper motor and the stepper motor controls the door opening and closing movement. Port A fifth pin is connected to servo motor, which is used for locking and unlocking of the door. Now let us see about the coding section of our project. We are going to do our programming in an integrated development environment known as Micro C Pro for PIC. I already pasted the code here. Let's configure the project settings. Let the MCU clock frequency as 20 MHz and name the device as PIC16F877 microcontroller. The library we are using in this projects are C standard library, C type, 4x4 keypad, LCD and LCD constants. The first part of the code shows that the LCD pin RS enable and D4 to D7 are connected to port D and the direction is configured using TRISD. Next we configure keypad. The keypad is connected to port C. The keypad port is used to access it. Then we configure the ultrasonic sensor pins. The trigger 1, trigger 2 and echo 1, echo 2 pins are connected to port D. And for password logic, we are using two arrays. They are correct password and entered password. In correct password, we store the predefined password. In entered password, the password entered by the user in the keypad is stored. And we have several modules below like compare password, which is used to compare both the correct password and entered password. Only if both the arrays matches, the door will unlock and open. Keypad mapping is used to configure the input of the keypad. And several other modules also included in the program like servo lock, servo unlock, which is used to locking and unlocking of the door, stepper clock, stepper anti-clock, which is used for opening and closing of the door. We also configure ultrasonic sensor to detect the presence of the people. In main function, we used a system init of where we have defined the input and output in the above part of the code. And second, we used a servo lock of because our system will initially in the lock state. Now we open the while loop. At first, the LCD will display prompt enter password. The user can enter the password via keypad. It will be stored in the array entered password and compare with the correct password array. If the password matches, the LCD will display password correct and it will enter into monitor state, where the ultrasonic sensor is used to count the number of entry and exit. The entry and exit detection is programmed in a way that it has four states. First state is state 0 or idle state. This state is to identify which sensor detects the object first. That is, if sensor 1 detects first, then the flow of the code is sent to state 1. Likewise, if sensor 2 detects first, the flow is sent to state 2. The next state is state 1 or entry detection state. The flow will come to state 1 only if sensor 1 detects first. And also if sensor 2 detects secondly, it confirms the entry and increment the count and move to state 3. Likewise, state 2 is also known as exit detection state. Here also flow will come to state 2 only if sensor 2 detect first. And if sensor 1 also detects an object, it confirms the exit and decrement the count and moves to state 3. State 3 is known as a reset state where it is resetted to state 0 and get ready for next entry exit detection of the people. The last part is automatic door control logic where we already calculated a timer count of 760 is needed per 10-second delay in timer 0. This 10-second time delay happens only when the count of the people inside the room reaches 0. That is, it closes the door after 10-second time delay with the help of timer in the microcontroller unit. After the door is closed, the LCD shows the password prompt so that only after entering the password of the door can be opened again. This is the explanation of the code. Now save the project and build the project to generate the hex file. Let's see our project simulation result in Proteus environment. This is the PIC16F877 microcontroller. It is connected with the oscillator of 20 MHz frequency crystal. This is a simple reset circuit for our microcontroller. And we have connected all our components as shown in the block diagram previously. Now let's import the hex file in the Proteus environment. Right click at the microcontroller, edit properties. Now load the hex file in the microcontroller. Now set the oscillator frequency as 20 MHz. So we have dumped our code in the microcontroller. Now let's check whether it is working properly. Now run the simulation. As soon as we run the simulation, we can see our servo motor is in locking state, because we initially it will be in lock state and we can see the LCD display. Now let's try a combination of wrong password and see whether the system opens. Once we type the wrong password, the system shows wrong password in the LCD, and the servo motor and the stepper motor is not rotating because we have typed the wrong password. Now let's try to type the correct password, that is 123, which we have predefined in our code. Once we type the correct password, the servo motor will be unlocked and the stepper motor will be also rotate in clockwise direction, which is used for opening of the door. And after the stepper motor is open, we can see the display message of count values, and it is in monitoring state. So it is waiting for the entry and exit detections. Once we trigger the first sensor and second sensor in the sequence, we can see there is a entry and the count value is 1. Now let's see the exit sequence detection. Now let's trigger the second sensor and the first sensor. We can see there is a exit and the count value is decremented and it is returned to 0. Now we have designed our system in a way that when the count value reaches 0, there will be a 10-second delay, and after the 10-second time delay, the stepper motor will rotate in anti-clockwise direction, which is the closing of the door. After the stepper motor is closed, we can see that the servo motor will move to 0 degree. That is, it is unlocking the door. And once the servo motor locks, we can see that in the LCD display, enter password prompt is shown. That is, the user can again enter the password correctly and enter the room again. Thank you for watching this project demonstration.